So today I'm going to talk about ZIO Test. ZIO Test is a test framework for Scala, and the key differentiating feature of ZIO Test is treating tests and effects as first-class values. So if you've ever done testing before with ZIO or with other functional effects systems, you can have this problem that when you go to run your tests, you find yourself doing unsafe run everywhere because your test framework doesn't know anything about Monix or ZIO or Cat's effect or any of these things. At best, it knows about future. And so we end up forgetting all of this information and structure we have in these effect types we've created when we go to run our tests. So ZIO Test is really what happens when we don't do that and we leverage all the power of the effect systems we've built to do testing. The goal of this talk is not really to go through all the features of ZIO Test. I did another talk in London in December that kind of did that, but rather to walk through how we can add test coverage to a simple application here and really show you how you can get started with ZIO Test in 5 minutes writing tests for yourself, and how we can scale up from that to starting to do some pretty powerful things with it. So for our exercise today, we've got this, this simple GitHub web app that I've created. It's kind of inspired by a blog post that Adam Worski did about using STTP and Polynote, but I'm not using Polynote here. And so what we've got here is we've got a simple data model here. We're going to have a set of search results that are going to give us a list of repositories. Each repository is going to have a full name, so that would be like ZIO/ZIO Kafka. And we have methods on that to get out the ZIO part and the ZIO Kafka part. And then we're going to have a contributor who has a login, so that would be like Adam Fraser on GitHub, and a number of contributions they've made. And then we're using the module pattern here, so we've got a GitHub service that has two methods. So one is this get repos that gets me to put in a language and a limit of how many results I want to get. And it's going to give me the top repositories in that language. And then we've got a get contributors method that's going to take a repository and give me a list of the contributors to that project. And then here I've got my actual live implementation that does all the logic of using the STTP client, creating a request with the appropriate information, and actually sending that request. Got some accessors for that. And then I've got a little bit more of my business logic here. So one thing we want to do is Scala Steward's great for keeping all of our projects up to date, but probably does a lot of PRs to a lot of different projects. So if we say that Scala Steward's the top contributor, that's probably not quite what we want to say. So we're going to exclude Scala Steward here. And then we're going to try to get the total contributions by user for across all these different projects. So we want to say kind of who are the most active contributors across kind of top Scala projects, however we define that. So we're just going to essentially sum up the contributions that each contributor makes to different projects that we're looking at. And then finally, we've got our actual program logic here. And so we're going to call that get repositories method with a language and a limit. And then for each repository we get back, in parallel, we're going to get the contributors to that repository. We're going to flatten that down to a single list of contributors. We're going to filter out Scala Steward there. And then we're going to group the contributions by user. And so we're going to get back here a sorted list of contributors with their contributions. And then for our actual program, we're going to generate the HTTP client from STTP. And we're going to provide that to our GitHub service. And then we're going to take that whole thing and provide it to our program here. And here we're going to start with the top 25 Scala repositories. So if I run this, complaint doesn't have a logger. And there we go. And so if we scroll up to the top here, We can see some familiar faces. Switch to playing. Okay, great. So this is cool. So we're ready. We'd like to write some blog post and kind of share our knowledge with our friends and show people what we've learned about using ZIO and integrating with other tools. But we want to make sure that we don't have any bugs here or things where we're going to do our blog post and then we're going to get 10 people commenting of, oh, you did this wrong, you did that wrong, you did the other thing wrong. So we'd like to add some test coverage for this. So to do that, we're going to go to this GitHub spec here that I've created. And I've just so far created just a basic skeleton of whenever we do tests with ZIO Test, we're going to create an object and we're going to extend this default runnable spec trait from ZIO Test. And then I've just created a basic model of some test data here. So test data is going to have a language, a repository, and a list of contributors. And then I've created one value here. This is a managed effect that's going to return some test data from a file that I've created here with just some information on contributors to a couple of repositories that are in kind of the ZIO ecosystem. And it's going to let me do something with that data, and it's going to make sure that I close that file as soon as I've done something with that data. And then when we extend that default runnable spec, we need to implement this one method spec that's going to have a set of tests. So a spec can either be a suite that can contain other tests, or it can be an individual test. So right now, let's start by creating a suite to have all of our tests. So let's call this Scala in the city spec. And then that can have other suites inside it. So why don't we start with one that we'll call unit tests. And so to warm up here, let's start with a couple of simple unit tests. So any test we create in ZIO Test, we can either use test if the test is testing a pure value, or test M if we want to use effects within our test. So right now, let's just create one of the easier methods here is this not Scala steward method. So let's say that not Scala steward excludes Scala steward. And so I can say my input is going to be an empty list of contributors. My output is going to be not Scala steward of my input. And then with ZIO Test, we use assertions to compare values to what we expect. So we use assert for that. And here we could say, actually, let's say this is list, contributor, Scala steward, and let's say that he's made 10 contributions. And so we want to say assert output. And we can always use a simple equal to assertion, but we also have more specific assertions for all sorts of common things. So here we can say assert that is empty. And so here, if I run test, there we go. So already I've got ZIO Test working. I've got my first test going. Awesome. So the next thing we can look at is how do we run property-based tests? So one of the really neat things about ZIO Test is that property-based testing is built in out of the box. So we don't need to bring in any, it's not like, well, we're using Scala test and now we need to bring in Scala check to do it, and everything works together just out of the box. So for that, let's say that we want to check this contributions by user method. So this one that's going to group up the contributions by user from different repositories and make sure that this is working correctly. So to do that, first we'll create some generators. So let's say gen contributor. So this is going to be a generator. It's going to involve random data, and it's going to return a contributor. And we can just create our generators using simple for comprehensions here. And one of the things we really try to do in ZIO Test is be explicit about generators. So typically our data actually has some constraints to it where it doesn't get reflected. We kind of have that like arbitrary generator, and having to go back and forth between the arbitrary and the gen can kind of mix things up. So we really try to be explicit about this. And this is a good example of this, of if we just generated a bunch of totally random contributors here, we probably would generate a set of data that didn't have overlaps on names, so wouldn't actually check what we want to check in terms of aggregating them appropriately and removing duplicates and things like that. So instead, why don't we say we've got a fixed set of contributors here. So let's say the name is going to be A, B, C, D, E. And let's say contributions is going to be an int. And this is another example where it doesn't make sense for contributions to be negative. So let's say it's going to be a number between 1 and 100. And then we're going to yield a contributor with that name and that number of contributions. So then when we want to do property-based testing, all we do is we use this check method if we don't want to use effects within our property, or we can use check M if we want to use effects. So here we don't need effects, so we're going to check, we're going to do a list of contributors. And we'll say our output is equal to contributions by user of the input. And let's make a, so one property we might want to have is we might want to say that these values should be distinct. So result is distinct because we're adding up the contributions user. So once we do that, we shouldn't have duplicates. So we can say assert output, and we've actually got a assertion for that. And then let's see what I'm doing wrong here. Oh. And then this test is actually using effects because I'm generating random values here. So there we go. And then I can test that. And there we've got property-based tests. And one of the really cool things here is that all of these things integrate together. So like these generators can use effects as well. So right now we're just generating random values using simple data here, but we could have a generator that loaded the generated data from a file there. We could do whatever we want there.
Adam, so sorry to interrupt.
Yes.
Could you zoom in a little bit? We've just got someone asking if you could zoom into your coding just a little bit, if that's okay.
Yes, let me.
Thank you.
Can people see better there?
Is that better? Hopefully. Yeah, that's better. Thank you.
Okay, awesome. Yeah, definitely. So let's add one more property-based test here. So another thing is we want to make sure that the results are sorted. So we could do the same thing. And again, I could do it myself by kind of sorting it and saying it's equal to something that is sorted, but we've actually got a is sorted assertion here. And here we're just going to take the output and we're going to map it to the contributions because those are the things that should be sorted, that should be sorted. And so this test is actually going to fail because I made a slight intentional error here of the results should be sorted in descending order, but the normal sorting is in ascending order. But what we can see here is the shrinking that comes built in with these generators and how the generated values always obey the constraints of the shrinking. So you see here, we made a mistake here and we got the minimal failing example here of 2 contributors with 1 and 2 contributions. It should be in the order 2, 1, but it wasn't in the order of 1, 2. So instead, we can just use is sorted reverse. And there we go. That test is passing too. So we looked at some unit tests, we looked at some property-based tests, but now one of the challenging things is that most of the logic of this program actually involves interaction with this GitHub service, which is going to call this live service. Maybe it's not available, maybe it's changing, maybe we're going to be rate limited. So how do we test this in a reliable way? And this is where the module pattern is really going to come in to help us out. Because since we defined that this whole GitHub thing is a service, we can provide a different implementation for it with ZIO Test. So let's say val test GitHub. This is going to be a Z layer that's going to require a list of test data. And it's going to return a new GitHub service. And I'm going to use the Z layer from service constructor here, which is going to give me access to that test data that I'm depending on. And then I can create a new GitHub.service. And so if I've got this test data, then I can get back, I can implement this get repos method by saying test data.filter language equals language dot take limit results. And then I need to provide this all in a task. So I'll just wrap it up there. And then similarly, I can implement this method as test data.find blank.repo equals repo. I'm okay with failing if it's not there. So I'm going to call it get. And then I'm going to get the contributors from that. And again, I'll wrap this up in a task. So now I've got a fully testable implementation of this GitHub service that I can just plug into my tests. So let's create another suite for this. So now I can say my actual output here is going to be what I get when I call this top contributors function with Scala. And I've only got 3 repositories I put in my test data. So we'll just use 3 there. And then if I'm testing something that's in effect here, this is a ZIO, then I can just use assert m instead of assert. So I can assert m that actual, and then I can use this contains assertion to test that it has a certain value in it. And I'm gonna pick a little bit more on Itamar because he's a colleague of mine. And so in this data, he shows up twice with 97 and 44 contributions. So that would be 141 contributions total. So I can say contains contributor indeed 141. And then I need to provide my test implementation. So I'm going to use this provide custom layer shared. And we'll just do one more thing here. No, I'm fine. Yes, so I'll just say my test environment. I'm going to take that test data that was a managed. I'm going to convert it into a layer, and I'm going to send that to my test GitHub service. And then here I can provide my test environment. And we'll test that. And there we go. And so notice what we've got here. So now we're running this with we've replaced the actual implementation of our GitHub service that do real web calls with this test implementation that is just going to use data from this file. We've done this in a pretty straightforward way without having to change any of our actual code, because we were just able to provide this different test implementation. And by combining these together, and the fact that all of this is using effects and is using this managed data type, we have a guarantee that when we use the data from the file here, we're going to open the file before this test, and we're guaranteed to close this file after this test. And right now I'm only using this data in one test here, but because I provide this as a shared dependency to this entire suite, if I add additional tests here, these are all going to use the same data from the file, only loading the file once at the beginning of this suite and guaranteeing to close the file at the end of the suite. So already, without kind of doing a lot, we've gone from these basic unit tests to managing resources and doing it in a way that's composable and has these strong guarantees associated with it. So, okay, this is all great, but we also need to actually test that the logic of our HTTP is correct and that we're doing the appropriate calls and that we're actually getting responses back. So let's see how we would do that. So let's create another suite for that. So let's call this with live implementation of GitHub service. And so again, we're going to do this top contributors. This time, just so I don't create any issues with getting myself rate limited, I'm just going to grab the top repository, which I think is Spark. And then I'm going to map that to just the logins. So we'll call this login results say. And then I looked this up right beforehand. The top contributor to that project is this gentleman. And then this whole thing, I'm going to provide the live environment. The live environment could actually fail with a throwable because it's actually doing real web calls. So if that's the case, I'm fine with just failing my tests. So I'm going to use or die here and then that right. I ran things instead of testing. Okay. And there we go. So now we've gone all the way from doing unit-based tests to property-based tests with test data and then with the live implementation. And this is where you also start to see the power of doing all these things as effects and being able to compose them together. Because you could imagine that maybe this is going to be flaky because this GitHub service isn't always going to be available for some reason. So how could we deal with that? Well, So we've got these things called test aspects that let you modify these tests. So for example, one of them is retry. So we could retry, and then we get to use this whole schedule data type that ZIO has for managing repeats and retries. So we could say, if this live service isn't available, then we're going to retry it with maybe a exponential backoff schedule, starting with 1 second. But then we don't want to do that any more than 5 times. And maybe we also want to say that this whole test is, we don't always want to run it. Maybe we want to run it on, we do our CI server, but not when people are testing locally, because we don't want just like every guy who's like rerunning their tests to be like pinging the service. So you could use this if environment set combinator, and you could, let's just say if an environment variable of CI is set, then run this test, and otherwise don't run it at all. So now, when I call test here, we see that it ignored that test. So this is a little bit of an overview of the functionality that you can get from ZIO Test. So by having tests as values and having effects as values, we get to use all the tools that we have in ZIO when they're built around the ecosystem in terms of effects, repeating effects, managing resources, interrupting effects. So this whole thing, one thing that's often really useful is to have just some kind of timeout for each of your tests. And notice that here timing out is actually going to work because ZIO effects can be interrupted versus in a lot of test frameworks, if you do a timeout, you're timing out, say, a future that can't be interrupted. So you're kind of failing the test after a certain time, but the test is, there's something that's happening, that thing is still running. So you get all these abilities and you get to bring them into writing your tests. So hopefully this gave you an overview of the power that you can get with ZIO Test, and also how easy it is to get started. There was really no magic here. All I did was took the basic dependencies out of the documentation, extended default runnable spec, did def spec equals, and I was able to start writing my tests. So hopefully this gives you some encouragement to try writing some of your own tests in ZIO Test. If you have any questions or run into issues, or there are more features that will be helpful to you, please visit us on our Discord or on GitHub. And I'm also going to be doing a workshop at the end of June on testing. So if you thought this was exciting and you'd be interested in learning more, would love to have you there for that. And with that, I will hand it over here.